I'm Otto van Geet from the National Renewable Energy Lab, which is in Golden, Colorado in the United States. You know, I think it is fairly easy to get a handle on the overall costs of data centers. You can kind of break the cost down into first cost for building the building, which includes all of the infrastructure, which I'll talk some more about. First cost for buying the computers, and then eventually you've got to get to operational costs also. And then there's staff costs to run the computers. But there's first costs, which are capital costs, then there's operating costs in energy and staff. So the options available are actually to optimize all of those. And it's worth talking about all of those. So when you're optimizing, when you're looking at the life cycle cost, which is the cost to build it and operate it across its life cycle, you want to optimize all those. So you want to make the building as efficient as possible. That's quite obvious, but what that means is that you want to minimize wasted energy. So you want all the energy, in the case of data centers, to go directly to the compute. That means that what you want to get rid of, or at least reduce as much as possible, is the other energy users. In data centers, typically those are computer or chillers first, or some cooling equipment, maybe uninterruptible power supplies or the power distribution chain. But the biggest opportunity is to make the cooling of the data center as efficient as possible. By making the building as efficient as possible so it can run efficiently, then you can reduce the energy use related to the operating cost, that third piece. Staff time is staff time, but obviously you want to optimize that for your workload problem. That's a more difficult discussion. And what I see, what the sector needs is to build equipment that can be cooled for free, using the ambient environment to cool it. That could be either just bringing in air, from outside through fans, or bringing in warm cooling water from any number of sources. So not having any chillers, which cost you money up front and cost you a lot of money to operate. That's the biggest problem. And that's one I wanted to talk a little bit more about. So getting it cooled for free, and then on the leaving side, now you've got waste heat. All those processors, all those watts turned into heat. If we can do something useful with that heat, reuse that waste heat, and the warmer the waste heat is, the more you can use it. So that's been a lot of our focus is to make it cooled for free, no chillers, and then to use the waste heat to do something useful with. We've come up with a metric, energy reuse effectiveness, or ERE, the Green Grid has, to measure how to calculate that, similar to like a PUE. It's a PUE with energy reuse is how you could think of it. Now you can go to making your operating cost, so at least you haven't spent more energy to reject the heat. You can now take that heat and move it to, say, heating your laboratory building or your office building or your swimming pool, your greenhouse, anything like that. That's a key metric that's not industry-wide, not being addressed very well yet. Our latest data center, our HPC data center, high efficiency computing, uses warm water liquid cooling. We happen to be able to make it for free for about 24 C, and then it leaves at about 40 C. And then we take that 40 C water and then use it to preheat the ventilation air for our lab building, which is adjoining, and use it to heat our office building. In Colorado, it's a fairly cool climate, so we have a lot of heating. So we see that as a key metric that the industry hasn't addressed well yet. But as we start moving towards higher temperature servers and hopefully maybe at least in HPC liquid cooling, once that warm liquid is in liquid form, it's much easier to move than air. So that's where we see the HPC industry moving towards direct liquid cooling for free, and then using that waste heat, rejecting the heat, and then using that to cool the computers again. So there's using the waste energy. That's where we see it going. So visualization of energy use metrics, things like PUE, ERE, and just kilowatts. How much am I using? How is that related to useful workloads? Having that in a visual display in your lobby so everybody can see it and say, hey, why are you using so much energy? Things are running really well. Our PUE is very low, and we're getting a lot of compute work done. That's very important to have performance metrics. Another one that we see up and coming, sort of like energy reuse effectiveness, is carbon utilization effectiveness. Like a PUE, but the carbon impact of our energy use, or of our computing energy use.